Hello, Stanford Algebra students. This lesson is on adding and subtracting polynomials. This is generally something you guys have been doing basically since 6th grade, but not realizing that you're truly doing it. When we look at the first example here, in the quantities these are each polynomials, and you can see in between them we are adding them. When you add polynomials, all you're basically doing is dropping the parentheses, so you can basically ignore the parentheses, right, and combine like terms. That's why I say it's pretty much the same as what we've been doing in the past, because all you really are doing is combining like terms. So if I take 9x to the third, its like term is negative 14x to the third, negative 11x, oh, no like term to it, then we have negative 8x to the fourth, we have 7x to the fourth, and then 6. Notice how I try to identify which ones are like terms. Now, once I go to write them, I basically start with the highest exponent. Negative 8x to the fourth plus, I look at the sign in front, plus 7x to the fourth. Negative 8 plus 7 is negative 1. And all I do is carry the variable expression over. I like to cross them out to let myself know I've used them. And I go to the second highest exponent. So I have 9x to the third, but since there's the minus sign in front, it's going to be 9x to the third minus 14x to the third. 9 minus 14 is negative 5. Carry over the variable expression. Cross them out. I've used them. Now, negative 11x. Oh, there's no like term, so minus 11x. And then I have my constant plus 6. And I have added those two polynomials together. Subtracting polynomials is no different. The only thing you have to remember is if you're subtracting, that negative sign has to get distributed. It's basically multiplying every term by this negative 1. This first polynomial doesn't change, so I write it down. 6n minus 5n squared plus 12. Then negative 1 times 3n squared is minus 3n squared. Negative 1 times positive 3 is negative 3. Negative 1 times negative 9n is positive 9n. And now, when I go to combine like terms, 5n squared minus 3n squared is going to give you negative 8n squared. Cross them out, I've used them. I go to the next highest exponent. 6n plus 9n is plus 15n. Cross them out, I've used them. Then 12 minus 3 is 9. And that is what we get when we subtract these polynomials. Okay? The next example. I look at this first polynomial. Do I have anything on the left here to distribute? No. So I rewrite the polynomial. Negative 7n to the fifth minus 7n plus 8n squared. When I look at the next polynomial, out here is a negative sign. So what do I have to do with that negative? I must distribute it. So negative times a negative makes that positive 12n to the third. Negative times a positive makes that minus 10n. And then I look at this last polynomial. Since I'm adding it, nothing changes inside. So all I do is rewrite that polynomial. So once I have that, I again start with the highest exponents. Negative 7n to the fifth plus 3n to the fifth, that'll give me negative 4n to the fifth. Remember, you add or subtract the coefficients, but you leave the variable expressions alone. So I have n to the third next. 12n to the third plus 13n to the third gives you plus 25n to the third. Cross them out, I've used them. 8n squared minus 13n squared. Notice how when I circle these, I include the sign to the left. That is going to give me minus 5n squared. Done. Okay, then I have negative 10n, negative 7n, and positive 10n. Well, negative 10n plus 10n wipes those out. And what am I left with? Minus 7n. Do I have any constants in here? No. Therefore, I am all done. Okay, so the one thing you have to remember is you add or subtract. First, distribute any minus signs. Then, When you combine like terms, you add or subtract the coefficients. Do not change the variable expressions. And make sure that you've accounted for every term once you are finished. Number 4. Notice to the left here, this is 2 times the quantity, which means anytime I say 2 times, that means I have to distribute. So 2 times 3x squared is 6x squared, plus 10x, minus 6, minus 20x squared, plus 16. So now, once I'm done distributing everything, remember I had to distribute this negative 4. Combine them. 6x squared minus 20x squared is negative 14x squared. Done. 10x, no other x's, so plus 10x. Then negative 6 plus 16 is plus 10, and we are done. Okay. Now the last one here, find the perimeter of the rectangle. Remember, when we look at a rectangle, you have your width and you have your length. Alright, and these could be switched, it doesn't matter. What you have to understand is opposite sides are always going to be the same. And anytime you find the perimeter, you're basically adding up all of these sides. So in this case, you would say the perimeter is W plus L plus L. Well, first thing in this example we want to do to find the perimeter is you basically want to label the opposite sides the same. 4x minus 3, 4x minus 3. It's going to be 2x squared minus 6x plus 5. Now when we go to find the perimeter, we can add all of these together, such as 4x minus 3 plus 4x minus 3 plus that 4x minus, plus the 2x squared minus 6x plus 5 plus the other side minus 6x plus 5. But since we're adding all of these sides up, you could basically ignore all of the parentheses. You could basically just drop the parentheses and combine like terms because you have no negatives inside here. Now me personally, whenever I'm finding the perimeter, what I like to do is just label the opposite sides and then just combine like terms from the sides themselves and say 2x squared plus 2x squared, 4x squared, used them. Then negative 6x plus 4x minus 6x plus 4x. That's going to give you basically negative 2 minus 6 is negative 8 plus 4 is negative 4x. Cross them out, you've used them, and then you have your constants. 5 plus 5 is 10, minus 3 is 7, minus another 3 is 4. And that would be your perimeter. And the same thing would be is if you combine like terms, you would get the same answer here. Thank you very much for your time, and try the next set of problems on your own.